Okay. All right, so we use the square root property. If I go back to my notes here, when do we use the square root property? When the equation can be written without a bx term. Okay, so those are the ones that we were doing yesterday. Yep, but we're on this right now, so we don't need any markers just yet. And then if I look at this example right at the top of my notes today, I see I have a bx term. Okay, so this is a slightly different method. It's called completing the square. Okay, and we use it when we have an equation that we can't factor. This one will not factor. As much as we try, it won't work. And then these are the steps that we're going to follow. Okay, but let's fill this part out. I can solve by completing the square. That's what we're going to be able to do today. Solve by completing the square. Most important word in that sentence is the word square. So what do y'all know about squares? Like a legit shape, a square. Like what do you know about squares? It has 4 sides. Yep. And what do we know about all those sides if it's a square? They're equal, right? So if the side of the square is 5, the top of the square is 5. The length is 5, the width is 5. So if I had a square, let's just say I had a square where the width was x plus 5, what would be the side? It would be the same, x plus 5, right? That's what a square is. Cool. Good. That is the one piece of knowledge you got to have coming into this, is what a square is. All right, now, follow my logic here, okay? We're just going to follow these steps and see what happens. So we're going to solve this. Step 1, rewrite the equation in the form x squared plus bx equals c. All that means is we want the constant number on the right side. Normally we want it like this, right? But not for this method. We want the constant on the other side. So in our problem, how do we move this 11 to the other side? By doing the opposite, which is adding. Yep, so we're going to add 11 to make it go away. And when it reappears on the right side, it's going to be a positive 11. So now I have x squared plus 6x equals 0 plus 11 is 11. Okay. Now, this next step is the whole shebang in one step. Step 2, add to both sides the term needed to complete the square. Okay, I know that sounds weird, but here's what we're going to do. We're going to add something to both sides. So I'm going to just set that up. I'm going to rewrite this, x squared plus 6x plus blank. So I'm adding something to that side. And then on the other side of my equal sign, I have 11. And the rules of algebra say if I add something to the left side, I also have to add something to the right side. Okay? So I'm going to be adding something to both sides. The question is just going to become, what is it that I'm adding?
You're going to multiply the x and c?
No. What I'm going to do is so remember, this is going to be a square. So here, I'm going to draw this box again. Okay? And we have to figure out this square. All right? So we know x squared, that goes in this part of the box, right? And then we know that these two boxes have the x on them. And then we have to think of something else. This right here is a square. If it's a square, the side and the top have to be the same, right? All right, so think about what these numbers are going to have to be. They're going to have to be the exact same number. And combined together, what do they have to add up to? 6, right? So what will these both have to be? What numbers will these have to be? 3 and 3, yes. Because that will make them the same number, and then they also add up to 6x. So if I look at the side and top of my box now, I have x plus 3 and x plus 3, and here's the big question. This is why it's called literally completing the square, because the number that goes there completes the square. So what number goes in that yellow box I just colored in? 9. Yeah, because 3 times 3 is 9. So the number 9 is what completes the square. So the number 9 is what I add to both sides of the equation. Okay? Now you might be like, cool, but what does this matter? How is this helping us? Well, this represents the box, right? Well, what are the factors of this trinomial? It's x plus 3 and x plus 3, right? Well, what's another way of writing x plus 3 times x plus 3? X plus 3 squared. So this is the same thing as x plus 3 squared equals, what's 11 plus 9? 20. And now look at what we have now. We have something that looks a lot like, I'm just going to pick an example from yesterday. This looks like example 2 from yesterday. So once I get it here, I did step 3, factor the perfect square trinomial. Now I solve using the square root property. So square root property says now, all right, I have to square root this. Positive and negative, square root of 20. So now I have x plus 3 equals plus or minus square root of 20. And then we just have to, we have to figure out the square root of 20. Well, is 20 a perfect square? No. Where did I get the 20 from? 11 plus 9. I added those together to get the 20. And then I square rooted because I'm trying to get x by itself. Okay, so I'm not going to be able to simplify the square root of 20. Well, I am, sorry.
Now you're going to put the negative 3 down?
So now I got to work with this 20. So what times what makes 20? 210, 4, 5, it doesn't matter how we do it, right? But once I get a prime number, I circle it. And then 10 is 2 times 5, and those are both prime. And then I look for a pair, right? I have a pair of 2's. So 2 goes in front, and then 5 is stuck under the square root. So I'm going to replace my plus or minus square root 20 with plus or minus 2 square root 5. So now I have x plus 3 equals plus or minus 2 square root 5. That's almost the answer. I have to get x by itself. Now I just subtract 3. But remember, I'm not going to write minus 3 after a square root because we don't do that. So we're going to put that minus 3 in front of the plus or minus. So our final answer is going to be negative 3 plus and minus 2 times the square root of 5. And that's fine to put that in our solution set. Or you can split it up and say one answer is negative 3 plus 2 square root 5. And the other answer is negative 3 minus 2 square root 5. It doesn't matter how you state your answer, just this way or this way. Okay? Can I answer any questions on this one? We just got to try it a few times so we get the hang of it, because from here down, this is what we did yesterday. We're just adding this complete the square bit. Okay, let's try another one. Okay, I don't really want to flip back and forth, so I'm going to take another note sheet to look at my steps. So, here we go. We got another one. So, step 1, rewrite the equation in the form x squared plus bx equals c. So, we need to remove this 5 because it's not an x. We need only x terms on this side. So, we're going to have to add it because it's minus. So, now we have x squared minus 8x equals 1 plus 5 is 6. Okay, step 2. Add to both sides the term needed to complete the square. So this is where I'm going to add in those blanks. So I'm going to add something to the left side and to the right side. So I'm just setting that up so I know, hey, I've got to add this number to both sides. And then we have to figure out the number, right? Like, we can draw a little square to figure out what completes the square. Okay? Now, if you can try to see if you can come up with a shortcut as we go through these examples, great. But if we need to draw a square every time, that's fine too. So x squared goes here, x and x go here. It's a square, so these numbers match, and together they make -8. So what are the two numbers?
So every time you wanna try to like put the other number at the other side.
Correct. Yes. So what will these both have to be? -4. They both have to be -4 because they have to be the same number, and together they have to make 8. Have you realized you just cut this number in half and that's what you put here? Yeah. Okay.
Miss, I thought when like this negative and negative is positive.
These add together. So they add together to make -8. All right, so the sides of my box are x minus 4 and x minus 4. Now, the big question. Here's what we care about. This is the completing the square part. What number goes in that box? What completes the square? Positive, 16. It's always going to be a positive, right? Because like you were just saying, a negative times a negative makes a positive, so it's always going to be a positive number. So 16 goes in each of those blanks. Okay? Okay, so what we've done is we've created a perfect square. Here's the perfect square. So what's its factored form? X minus 4 times x minus 4, right? But I'm not going to write it like that for this method. I'm going to write it as x minus 4 what? Squared. Equals, now I'm going to add 6 plus 16. What is that? 22? 22. Okay, now this becomes a square root property question. Now I'm trying to get to x, so I have to square root to knock out the square, and plus or minus square root of 22. So x minus 4 equals, and 22, let me just ruin it for you, it's not a perfect square, right? So it's just positive and negative square root of 22. Now we have to see, can we simplify that? So if I try to draw a tree with 22, what times what is 22? 2 and 11. 2 is prime, so we have a dead end. 11, also prime, also a dead end. Do we have any pairs? No. So all that means is we can't simplify this. So we're just going to leave it as plus or minus square root 22. But we do have to do one more thing to get x by itself. We have to add 4, and I'm going to put that plus 4 in front of the plus or minus square root.
Isn't it 32?
Isn't it 32? It's 6 plus 16. Right? So 6 and 16 is 22, right? Yeah. No? 16 plus 6? Why are you guys making me?
It's 22.
Okay. All right. I'm like, I'm 22. Use your fingers. 16, 17, 18, 19, 20, 21, 22. It's 22.
Also,
Okay.
it's not 26.
Are you trying to make a 6-7 joke? No? Okay. All right, so x equals 4 plus or minus the square root of 22. Okay. And since we can't actually add those together, Because this is a trash decimal, right?
Yes.
We are just going to throw that in solution sets. That is our answer. Whoops, square root 22. For plus and minus the square root of 22. Okay? So the new part is this completing the square stuff. All right. So I got one more to do with you, and then I'm going to have you try one on your own from CYU 10. Okay? All right, so let's consult our steps, because that tells us how to do it, right? Step 1, rewrite the equation in the form x squared plus bx equals c. Oh, this is not like that, right? This 10x is on the wrong side. This 5 is on the wrong side. So these need to switch. When stuff switches sides of the equal sign, what happens to the signs of it? It's just opposite, right? Like, think you're going to subtract 10x, so it's a minus 10x when it moves over here. And think we're going to subtract 5, so it'll be a negative 5 when it shows up on the other side.
So every time it's a number at the other side, we gotta switch it.
Yeah, because, well, yeah. So in order to do this method, it has to look like this. So anything with an x needs to be on the left side.
Okay.
Anything without an x needs to be on the right side.
Yes, ma'am.
Yes, okay. Now we do step 2, add to both sides the term needed to complete the square. So we add in our blanks. Plus something equals negative 5 plus something. Then we just got to figure out what is the something, right? And draw my box up here. A little more room. So this is x squared. This is x and x.
So
Okay.
it would be negative 5 and 5.
They would both be negative 5, yeah, because they need to add up to negative 10. So adding these together makes negative 10, and then if I look at my box, the number I really care about right here is,
Positive 25.
it would be positive 25, yes. Always going to be positive, right?
Okay, then.
All right, so 25 goes here, and 25 goes there.
Okay, baby.
Okay. Now, step 3, factor the perfect square trinomial. So that just means instead of writing it like a trinomial, write it in its factored form, which is x minus 5 times x minus 5, but we write it like x minus 5 what? Squared equals negative 5 plus 25, 20. Okay. Now we can solve the resulting equation by using the square root property. So get rid of that square. I square root.
No, the
Where does this come from? It comes from the side and the top of the square.
What about the 20?
Negative 5 plus 25 is 20.
So the first one, it comes from the side.
Correct. These are the same thing. This is just written in its factored form. Yes. All right, so now I've got, what do I have? I have x minus 5 equals plus or minus the square root of 20. And then we just ask ourselves, hey, oh, we did this one already. Square root of 20, if I get a trash decimal, that means I got to simplify it. But I think we already did the work for this.
And we,
Oh, right here. It's 2 root 5. So I'm not going to draw another tree. Can I just borrow the answer from here? Okay. 2 root 5. So x minus 5 equals plus or minus 2 root 5. And then last step, add 5. But I'm going to put the plus 5 in front of the plus or minus because we don't really have any business going on behind a square root. Okay, that's just, we don't need that. So x is going to equal positive 5 plus or minus 2 times the square root of 5, and we can just put that in our solution set. So these are going to have kind of weird looking answers because if they were good answers, we would just factor them. But the whole purpose of this method is for the ones that we can't factor. Okay? Okay, so here's what I want you to do right now, because we did those together. I want you to try one by yourself, and we'll go over it. So have a look at CYU 10. You picked this up when you came in. I'm going to give you a couple minutes, and I want you to try number 1. Okay? Use your steps.
Easy work.
Just try number 1, okay? Because I want us to all go over that one. And then after we go over that one, then you can split up working on several different things, okay? But everybody do that one right now. You're done? Okay, can I just see your time screen? Do you have it still?
Oh, yes. Can I see something in your example?
Perfect. Okay. I'm going to let you take that if you want to copy the notes, okay? You don't need it? Okay. All right. Thank you.
Yes, I have to do this problem first.
Yes. Yep, but we are working on this problem right now. That's what we're all doing.
Oh.
All right, you guys, you ready to go over it?
Yes.
All right, let's see how we did here. So following our steps. Step 1, rewrite the equation in the form x squared plus bx equals c. And it already is, right? There's nothing to rewrite. Step 2, add to both sides the term needed to complete the square. Okay, this is where we are going to add in a blank. And then we figure out, okay, what goes in the square? So it's, these numbers are both -3 and -3, which makes our side of our square x minus 3.
And it would be positive 9.
But the number that completes the square is 9, positive 9. It's always going to be a positive, right?
Yes.
So we add 9 to both sides. Okay, now I'm going to write the left side in its factored form, which is x minus 3 squared, right, equals, what's 8 plus 9? 17? Okay. Then we're going to square root plus or minus square root of 17. So x minus 3 equals positive and negative square root of 17. And then you can ask yourself, hey, do we have, like, can you do the square root of 17? And no, you cannot. You get a trash decimal. So then we try to break it up. If I try to break up the square root of 17, I just get 1 and 17. Right? 2 dead ends. So we can't simplify that. We just have to leave it like that. But in order to get rid of the minus 3, I'm going to have to add 3. So x is going to equal 3 plus or minus the square root of 17. Okay, who got that right all by themselves with no help? Okay, awesome, awesome. Now, keep in mind, while you're working on this paper is a grade, okay? This is a grade. But you can check your work if you just flip up the bottom. You can check your answers. Okay? Yep, there it is. Okay? All right. So, at this point, let me turn this off. Let me show you what the things are you have to do. And it's up to you.